Welcome back! Today we're diving into converting between standard decimal and scientific notation. Let's get started. Positive numbers written in standard decimal notation can be very large or very small. For example, 54 billion or 5,400,000ths. These numbers can be a bit unwieldy and cumbersome, but there's a simpler way to express them using scientific notation. Powers of 10 help us represent large or small numbers more easily. A power of 10 is an expression that shows a number as a multiple of 10 raised to an exponent. The general form is 10 to the power of n, where n is an integer. Let's look at a few examples of powers of 10. 10 to the power of 2 equals 100, because 10 to the power of 2 means 10 multiplied by itself, or 10 times 10. 10 to the power of 5 equals 100,000 because 10 to the power of 5 means 10 multiplied by itself 5 times, or 10 times 10 times 10 times 10 times 10. But what happens when the exponent is negative? 10 to the power of negative 2 equals 100th because 10 to the power of negative 2 means 1 divided by 10 multiplied by itself twice, or 1 divided by 10 times 10. 10 to the power of negative 5 equals 100,000th because 10 to the power of negative 5 means 1 divided by 10 multiplied by itself 5 times, or 1 divided by 10 times 10 times 10 times 10 times 10. Now, a number in scientific notation is written as a times 10 to the power of n, where a is a number greater than or equal to 1, but less than 10, and n is the exponent. Let's convert from standard decimal notation to scientific notation. Take 7 trillion. First, move the decimal point so it's between the first two digits, 7 and 0. Notice that 7 is now between 1 and 10, which is a key part of scientific notation. Count how many places you move the decimal. 12 places. So, 7 trillion becomes 7 times 10 to the power of 12. Next, for a smaller number, like 5,400,000ths, move the decimal point to between the first two digits, 5 and 4. For this time, you move the decimal 6 places to the right. So 5,400,000ths becomes 5 and 4/10 times 10 to the power of negative 6. Now, let's convert from scientific notation to standard decimal notation. Take 3 and 2600ths times 10 to the power of 4. Move the decimal point 4 places to the right. 32,600. Now, notice that when we moved the decimal point, we added zeros after the 326 to fill the empty places. This is because a positive exponent means we're dealing with a large number, and the decimal moves to the right to expand the number. Next, let's look at a number with a negative exponent, 4 and 7/10 times 10 to the power of negative 3. Move the decimal 3 places to the left, 4,710,000ths. When the exponent is negative, the number gets smaller, so we move the decimal point to the left. This is why we add zeros in front of the 4. A negative exponent shows that the number is less than 1, and moving the decimal left makes the number smaller. So remember, to convert from standard decimal to scientific notation, move the decimal point so that the number is between 1 and 10. Count how many places you moved the decimal. This becomes the exponent on 10. If you moved it to the right, the exponent is negative. If you moved it to the left, the exponent is positive. To convert from scientific notation to standard decimal notation, simply move the decimal point according to the exponent. Right for positive, left for negative. Count the number of places and fill in with zeros if needed. Thanks for watching, and as always, stay curious and stay fresh.